I'm Stanish, as Gary said, and I'm going to be talking about our experience in introducing CGNAT and IPv6 in Vivacom network. So here is a short about Vivacom Bulgaria. This is the former incumbent operator, also known as or formerly known as Bulgarian Telecommunication Company, now is Vivacom Bulgaria AD. As you can see, in 24, it got in privatization procedure, and since mid-2020, we are now part of United Group. So currently, we are the largest telecom in Bulgaria, providing limited 5G, 4G plans, LTV, IPTV, 10 gig fiber access, DTH, you name it. So we have received several awards for fastest mobile network in Europe, and we operate the most modern teleport in let's say on the Balkans, even in the world. So, before we proceed with IPv6, we should, of course, start with CGNAT, because the CGNAT was the predecessor of introducing IPv6. So, in 24, PTC introduced the first real broadband service. It was ADSL. Back then, life is very good. There were no any IPv4 shortages. We were able to get as much as needed IPv4 allocations from RIPE by only maintaining broadband verification statistics and doing some interaction with RIPE IP resource analysts. So, fantastic time. Then in 27, the mobile operator was launched, and once the data plans were offered to the customers, we started to use CGNAT from day one. So, you know, thousands of hundreds of subscribers, no way to do anything else but CGNAT. So, 2011, we started introducing fixed broadband services. This was AON, Active Ethernet, and GPONT. Back then, still no need to do CGNAT. We were able to get several /16 prefixes and even one /15 in order to meet the demand of increasing amount of broadband subscribers in the network. So far so good, but during the years there were definite and steady increase in the number of broadband subscribers, the bandwidth, and more and more during the years it was apparent that we are going to start suffering from IPv4 shortages. So the one solution and quick and dirty solution was to buy IPv4s, rent them wherever needed to get enough IPs to meet the demand. So in the early 2021, it was evident that this is not possible to continue because of the increasing cost for IPv4s, for buying, for renting. The cost has been increasing dramatically over the years, and finally we ended up launching CGNAT in December 2021. So from this moment we started migrating all existing broadband subscribers to the CGNAT after contract renewal, and all new subscribers were provisioned in CGNAT from the start of the service. So, why? The reason is that when you have millions of mobile subscribers, hundreds of thousands of fixed broadband subscribers, and on the other hand, the severe IPv shortage and the tremendous cost that we were able to offload by launching CGNAT. So CGNAT was a really nice solution for the problem for us. But then that is the reality. When you do CGNAT, you still need to have enough public IPv4s for the not CGNAT outside pools. You need to maintain them, you need to plan the increase because the subscriber amount is increasing. Then the problem with doing CGNAT by using hardware. So hardware is, it has limited capacity, it requires licenses. Licenses cost money, you know. So when the traffic grows, you need to put more hardware. The hardware needs rack space. If you use appliances for CGNAT, it requires router slot space if you use hardware integrated in the BNGs or in the routers. Hardware has, once again, limited capacity. It has end of life, end of support. It quite often becomes obsolete once you upgrade the software of the appliances. You need to maintain backup solutions, you need to maintain spares, and it's quite a worry. So when you do CGNAT, you have to keep records for dynamic mappings for the authorities. So when the authorities need to know who is using a certain address, they come to us and we have to provide information. So the logging could be done either for export, radius accounting, or the ultimate solution is to use deterministic NAT. So for the logging, you need logging servers, again capacity, you need administrations of the servers, and you see it's complicated. So when you do CGNAT, you must to do whenever and whatever is needed to try to offload the CGNAT hardware in any possible way. So this is called in our terminology CGNAT bypass. So companies like Google, Netflix, they have instruction how to configure your network in order to have CGNAT bypass in place with the purpose to offload the hardware. So the other problem, which is kind of daily problem, is blacklists. When you do CGNAT, you usually put, let's say, 40, 60, 100 subscribers behind one public IP address. And when somebody tries to do something which is resulting in blacklisting the IPs, it's worry, and it becomes problem for everybody behind the public IP address. So, okay. CGNAT is good, but not that good, eventually. So, we did a lot of efforts to offload the CGNAT, but last year it was become apparent that we need to finally introduce IPv6 as the next step in offloading the CGNAT. So let me do first overview of our experience with IPv6. November 27, we got our first IPv6 allocations. In August 2009, we got first business customer on dual stack. This was Sofia University, St. Klimatohritsky. So these guys are always ahead of the game. Since 2009, we have been providing IPv6 preliminary to business customers and in business VPNs. So the business customers having dual stack internet were directly configured on the broadband, on the border routers, since we didn't have IPv6 enabled in IP core network. So, for example, if we have a customer needing dual stack in Varna, we do layer 2 transport to Sofia and configure the customer directly on the border routers. So in 2011, we enabled IPv6 on our DNS caches in order to allow our old customers to use our DNSs, not the public DNS caches. You see, there is a kind of huge gap between 2009 and 2020. So finally, we decided to start working on our implementation of IPv6 preliminary for our broadband and mobile subscribers. So this is start of early test, as I said, on the PNGs. So in April 2020, we introduced the full IPv6 routing table in the entire IP core network of Vivacom. Then it became possible to move the IPv6 or dual stack customer, business customers from the border routers directly back to the edge where they belong. So the first IPv6 introduction was done in December 2021 on the mobile network for all mobile subscribers using 4G, 5G. Well, in 2021, there was only 4G, but anyway. So the introduction was after a short pilot in order to see on the field whether or not there will be any problems in order to fix them. And the pilot was successful, and we did full-fledged enabling of IPv6 for the whole mobile network. So during that time, we kept working on our IPv6 design for the broadband subscribers, the fixed subscribers. And officially, in February 2021, we started officially the project within the company to work on IPv6 in every department that has to be involved. So this includes the AAA system, the ACS. ACS is the ultimate. ACS is automatic configuration system, also known as ACS. Okay, so we worked on OLTs configurations, ONTs, and CPs because for the GPON service we have ONTs which are just bridge, and in such cases you need CP. That's why we have ONTs, layer 3, layer 2, and CPs. Also, we had to do low-level design in order to make it clear which has to be changed, configured, addressing plan, etc. So it looks like it took us a year to finish all the work. And officially on 31st of January this year, we activated IPv6 in the first city. It was done again in a small pilot approach. We did it for Yambo. There were like 2,000 or 3,000 GPON DHCP stations, and the pilot was success. No any problems, no any complaints. And what we have realized that 99% of the end users never realize that IPv6 has been enabled. It's absolutely smooth activation. So during last 5 months, we were enabling IPv6 on the entire network. We have only one maintenance window left to be done by the end of this week, and we will be finished. We will be done with the IPv6 activation for the broadband GPON service in Vivacom network. Meanwhile, during the years, there were several caching farms. Every operator has, let's say, Facebook cache farms, Google cache farm, Netflix, Akamai, Cloudflare. All of them were configured dual stack from the day one. So once we started to activate the IPv6, IPv6 for the customers, they naturally started accessing these resources over IPv6, thus offloading the CGNAT dramatically. So, during our tests, we decided to do classic dual stack approach. This means either public or private IPv4 address, and for IPv4 and of course IPv6 address, and if wanted, we provide /64 prefix delegation. So in mobile, now we have public or private IPv4 and 60/64 IPv6 dynamic or static. Every mobile device, which includes smartphones, tablets, 5G or 4G fixed wireless access CPs, are provided with /64. So it was really straightforward. In the mobile network, there are no such things like classic access network that we have in the fixed network. The authentication is done by the mobile core, and it was really easy. Now you will see what we had to do in the fixed network. So for the fixed network, we have dual stack, of course, for GPON subscribers, public or private IPv4. If the user uses, let's say, a Linux operating system, it will get /128. Or if they have layer 3 CPE or layer 3 ONT, they will get /120 or host, IPv6 host address on the WAN and 6/64 prefix delegation. For the IPv6, we provide only dynamic IP addresses. In the mobile, we are able to assign permanent /64. And for the fixed, we decided that this is not necessary for the time being. On the BNGs, we do only DHCPv6, no SWAC, only DHCPv6 access for the address and for the prefix delegation. On the BNGs, we are using a fantastic feature, which is called in the vendor terminology, IPv session. This provides us with the ability to do single authentication for both DHCPv4 and DHCPv6 sessions for the same MAC address. This results in 50% reduction of access requests sent from the BNGs to the AAA. Authentication is based normally for IPv4 on option 82 circuit ID, and for IPv6, option 18, which is interface ID. This is the thing that uniquely identifies the subscriber in our fixed network, in our GPON access network. So once again, dynamic allocation on the WAN and /64 prefix delegation for the ONT CPE. The CPs use the prefix delegation to provide addresses on its WAN interface. Usually, the classical implementation is SWAC. So on the BNG DHCPv6, on the CPs 1, SWAC. Of course, as you know, we have to keep records of identities which are using IPv4 addresses and IPv6 addresses. This is why we have introduced also radius accounting for IPv6 for the authorities to make check if needed or necessary. So we move on. So what had to be done? This is the, let's say, the list of tasks, but they were not done in this sequence. Some were already done during the initial tests. For example, low-level design has been maturing, let's say, for a year, until we decided the proper IPv6 implementation in our network. Then we needed to do IP core PNG's reconfiguration. This includes local DHCP server configurations, IPv6 filter, redirects, and so on. The BNG's configuration is normally done in 2 steps because it requires changes in the BNG which are not possible when we have active sessions. So we need to do initial configuration, then we prepare the rest of configuration in maintenance window. We disconnect the sessions, apply the changes, and put the sessions back again on the BNG. In the AAA and the ACS, for the AAA, only IPv6 accounting. So far, we decided once again that we are not going to provide permanent prefix delegations and static IPv6 addresses. No, nobody asks, as I told you, 99% of the end users never realized that IPv6 has been enabled. So this is the main reasoning. ACS, this is the system for managing the CPs. You know, when we have hundreds of thousands of CPs, we have to use a system to do mass configurations, mass enabling of IPv6, disabling, and so on. To run batch activities based on CP type, CP vendor, and so on. For the ONTs, of course, we had to assess which ONTs could support IPv6 and which has to be replaced, let's say. We had to do tests for that purpose, and of course, for most of them, we needed to contact the vendor to provide the software image supporting IPv6 and also supporting TR69. This is for the ACS functionality. TR69 support for IPv6 related functionality of the CPs. So, in the OTs, we did configure DHCPv6 snooping in order to have the proper security index for the IPv6 and also to make the OTs insert DHCPv6 option 18. This is the analog of option 82 circuit 18 in DHCPv4. Then we did IPv6 activation in batches. Let's say several small towns as a pilot first, then some big towns, and then the rest. So, as IPv6 was a kind of new thing in the network, we had to do training for the people operating the routers and people working with the AAA and ACS. So this is the final result. As you can see, this is the traffic distribution. In mobile, we have, this is actual from 2 days ago, let's say. We have achieved 38% of IPv6 traffic, which is actually traffic offloaded from the CGNAT. But still 62% of traffic through the CGNAT hardware. For the fixed network, it is almost, but not that the same, 33% IPv6 and CGNAT, but this is not including the biggest, let's say one of the biggest sites which are going to be IPv6 enabled on Thursday evening. So we are at the final. We are very happy with these traffic charts. It's real. And this is something that is maintained by Apnic. Here you can see the start of the peak. The start of the peak is the IPv6 introduction in the mobile network. So it was at the end of 2021. As you can see, 1 year later, there is another peak, and this is the moment when we started to activate IPv6 for our GPON service. So now we end up with this thing teaming up. So IPv6 and NAT working as a team, helping us reducing the costs for IPv4s, and especially for the CGNAT hardware licensing, etc. It was really, even for us, surprisingly smooth. So far, we have only one customer complaint, only one. Having in mind that we have over 36, let's say 360,000 active DHCPv6 sessions. Only one complaint, and it was one guy from Information Services, Rosin Popazov. The guys from Information Services know him, and he was complaining that Vivacom is not providing temporary prefixes. There was never intention to do this, so it's fine for us. For us, this is the most future-proof and sustainable next step when you have CGNAT in place. Literally unlimited IPv6 address space, and IPv6 traffic is increasing steadily day after day. Such companies like Cloudflare, you host your stuff on Cloudflare and you get IPv6 access to your resources. And we are going to see more and more CGNAT traffic offload steadily for the future. So our intention was to drastically solve this problem and move forward. So future plans, everybody has future plans. We will be trying to increase the CPs and ONTs and other access devices to have IPv6 support there, and that's it. Thank you. Any questions? Probably no questions, huh?
Lagoj from Spider, Macedonia. Is there any regulatory, I think in Bulgaria, some law for collecting logs for CGNAT?
The authorities require us to keep the logs for CGNAT and provide access to them whenever needed. So, for IPv6, I'm not sure that they have even realized so far that there is such thing like IPv6, and for sure it is not a new kind of MAC address. When you work with authorities, they normally say, please check this MAC address for activity in your network, or this check this IPv4 address, but they simply, this is my humble opinion, that for the time being, the authorities are a bit unaware of IPv6 presence in our networks and other operators.
And you have how much terabytes of space?
For CGNAT logs? No, don't know. I'm not dealing with this. Don't know. Anybody else?
Hi. My question is, how do you deal with the security team in regards to introduction of IPv6 in the network?
Security on the BNGs. The
Security team as a whole in your mobile network, in every part.
Could you please repeat?
How did you deal with the security team in your company about integration?
So we are doing
implementation.
We are doing the security. Yes.
Okay.
So
You don't have a separate security
we
team?
do everything regarding IPv6 security. And so.
No. My question is, do you have a separate security team that is dealing with security in the company as a whole? No. Okay.
Okay.
Anybody else?
Do you find this useful, new information? So we are kind of pioneering here in IPv6 because we had to. So here in Bulgaria, IPv6 is not so common. Except us, we know that the colleagues from A1, they have some IPv6 in their DOCSIS network, which is there was acquisition from A1. A1 bought this cable operator Blizu, and they were just running IPv6 on their DOCSIS network. Most of the people simply don't bother with IPv6 from the competitors. This is my humble opinion.
All right, thank you so much, Stanish.